Hello. Today we'll be solving problem number 1 from free response section of AP Calculus AB 2018. This is a graphing calculator problem, and obviously you'll see for lots of computations we will need a lot of power. So let's read a little bit the problem and try to understand what should we do with it, and maybe we'll find out afterwards a larger category for which this problem is just a particular case. I will read the problem, and I'm going to highlight some kind of parts of the data which I feel like are interesting and I need to consider. So people enter a line for an escalator at a rate modeled by the function r given by. So I have a rate at which the people will enter the escalator. It means that somehow I have the speed at which those people will get on the escalator. And r is given by the equation. It's a piecewise function. The first branch, 44 times t over 100 to the third power multiplied with 1 minus t over 300 raised to the seventh power for the time between 0 and 300, and 0 for anything higher than 300. Now, r of t is measured in people per second. That's very important for us. We need to know the units because this is one of the 9 points you can get for one of these problems for a free response question. And t is measured in seconds. So again, I need to have this part also highlighted such that I can keep it in mind. As people get on the escalator, they exit the line at a constant rate of 0.7 person per second. So people are getting into this rate, but they are exiting as well at a rate which is constant, 0.7 person per second. And there are 20 people in line at time t equals 0. Okay, that's also a very important piece of the information. Before moving on and trying to solve this equation, I'm going to write some little notes down, and maybe we can come up with a general case about this category of problems. So let's see how I can move out to some. So here is my problem. So I'm going to move it outside of this area, and I'm going to try to write down some facts that maybe will come up as a generalization of the problem I have to solve. So this is problem number 1 for the AP Calculus AB 2018, the free response part. And that's a calculator problem, yeah? So it's good to know because some of the computations will be way too difficult otherwise. So the general situation, as you have seen in this problem, it's something like this. There is a number of people, let's say a quantity at the time t, which is actually depending on the number of people who are already on that escalator line. So a quantity at time 0 on the action starts, plus a quantity that will be added systematically over a period of time. In that case, we have the rate at which the population enters the line. So I will name that A of t, like the added quantity. And as well, something happens. Some of the people will exit out of this line, and I will label that part of this equation E of t. So let's write a little bit down here what are the labels for this one. This is the quantity, generally speaking, at time t equals 0. That's the added quantity at time t. So this is going to be added systematically for a period of time. In our problem, for a time between 0 and 300 seconds. And this is a quantity that is eliminating also systematically from that big Q of t. So this is the exit quantity at time t whatever. So I think that now we have a way more general case of a problem rather than that particular one. And I'm going to name this case, and I'm not original in that, but let me use it, is the accumulation problem. With the specific case of in and out quantities. Now, I'm going to go back to my problem and I will try to see how can I solve this problem. So what is in that problem for me to solve? To my paper. Okay, so here we are. This is the problem. And let me try to solve that point A. So point A, I need to figure out how many people enter the line in the first 300 minutes. Since I have the rate at which the people are entering, R of t, it means that the number of people getting in line will be integral from 0 to 300 of R of t dt. Now, because this is a kind of complicated integral to get it by hand, I'm going to use a graphing calculator to estimate it. Here is my graphing calculator. In my graphing calculator, I have defined a function, r of x. I could have said r of t, but doesn't really matter how we name the variable. The quantity or the measure will be pretty much the same. Is 44 times x over 100 to the third power multiplied with the factor 1 minus x over 300 to the seventh power. Once you define that r of x, click enter, and then to find out the quantity we are looking for, select from menu integral and evaluate integral from 0 to 300 of r of x dx. The result is going to be 270. Well, this is interesting, but this 270 should represent something. And in our problem, these are 270 persons. So you will say, hey, how did you know that these are persons? Well, let's go back to our problem and let's remember what did we know about R of t and t. We know that R of t is measured in people per second and t is measured in seconds. So if I really want to know how the integral is going to be measured, is to symbolically write what will be the units for this integral. So let me label I the quantity I should get out of this integral. So in this case, 270. So I will say the units for I would be given by the units for R of t. So somehow, like in science, many times you play with this type of relationship, times the units of dt. Well, dt is the difference in time, so delta t, it's measured in seconds. And R of t, in our problem, we've seen that was measured in persons per second. So I'm writing this one formally right here. As you can see, second and second can be simplified, and I ended up with that integral representing actually 270 persons that entered the escalator in the time in our problem. So which was between 0 for the time and 300 seconds.